start recording so that the other people can just watch the recording later on. Yeah, so that was where I stopped at, right? Are you still all right with that particular question where I stopped last time?
Yes, I'm all right.
Okay, cool. All right, I'm just going to continue to the next chemistry questions, and I might come back to the physics questions if we have got time, lah. Right? I can't really do the biology question because my biology is pretty rubbish. Okay. So yeah, this next one is about respiration, which is actually biology. So in respiration, you know that you are burning the food that you eat. You're burning glucose. So that is the formula for glucose, and that burn in oxygen, and you breathe out carbon dioxide, and we give out water as well. So it's pretty similar to burning methane. So this is our organic chemistry. And when we burn hydrocarbon, because this is an alkane, so it's a CnH2n plus 2, we know this is a saturated hydrocarbon, which is your alkane, and they only contain single bond carbon-carbon, and of course, they only contain hydrogen and carbon atoms only. So those are common definitions they love to ask you about this. Can you tell me what is the test for carbon dioxide?
Add lime water.
Yep. So you don't actually add lime water to the gas, but you would collect the gas and you will bubble the gas into lime water. So adding lime water to the gas is a bit tricky, but if you collect the gas and you bubble it into a test tube filled with lime water, then what will happen to the lime water?
It turns milky.
Yep, so it turns milky, it turns cloudy. I think last time you saw me doing it in class, so those are very common stuff. I'm just going to jump straight to the last question first. So this is incomplete combustion. So that means not enough oxygen. When you don't have enough oxygen, you're going to get this thing called carbon monoxide, which is basically a carbon and a single oxygen. Mono means one, dioxide, CO2 earlier, two oxygen for the two carbon. Now, carbon dioxide is very commonly asked in dot and cross. So carbon for 4 covalent bond, because carbons with 2,4 electronic configurations, oxygen with 2,6 electronic configurations. So the carbons will form 1, 2, 3, 4. Each oxygen will form 2 covalent bonds. 1, 2 for this oxygen, 1, 2 for this oxygen. By knowing how to draw that, you can translate it into dot and cross. The double bond means the carbon donates 2 electrons there, so donates 2 electrons there. And of course, the oxygen also donates 2 electrons. So each oxygen share 2 there, each carbon share 2 there. But oxygens, we talk about outer shell, you only share 2 out of 6. You still have 4 more on the oxygen there. Similarly, on the right-hand side, I also have another double covalent bond. So there is 2 cross for these carbons. And then I have 2 dots for the oxygen there. And what I'm going to get is just 4 more oxygen electrons in the outer shell. So I have 6 dots to begin with and 2 cross on the carbon, 6 dots to begin with and 2 cross on the carbon. Carbon started with 4 cross, share 2, share another 2, carbon for 4 covalent bond there. CO2 is very commonly asked. That one can cause global warming because just like methane, methane can also cause global warming because they are greenhouse gases. So CO2 and also CH4, they are what you call greenhouse gases, and that is as stated in the environmental chemistry syllabus. It causes the whole world to become hotter there. Anyway, CH4 is your classic dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, dot cross hydrogen, because hydrogen forms single covalent bond. So when you draw methane, you can see CH, CH 4 times. So that is a CH4 methane there. I could imagine this kind of questions in the new syllabus. They will ask you about environmental chemistry. They will ask you about, dot and cross. They will ask you about melting and boiling point. Melting and boiling point. So we know CH4 and also CO2 is gas. So CH4 and also CO2 are gases. So CO2, CH4, They are what you call gases at room temperature and pressure. So what I could say is low boiling point. So they are easy to boil. They are easy to boil. The question now is, in terms of boiling points, it was stated in your year 9. Should probably recap your year 9 if you don't know these. We talk about what is the reason for the low boiling point. Number 1, we said simple covalent structure. This was in the year 9 property of covalent compound. Property of covalent compounds. So little energy or not a lot of energy needed to break something which is weak. So you're just breaking weak force of attraction. And these are called intermolecular. Hang on, yeah? Intermolecular. Inter mean in between. These are intermolecular forces of attraction because all you are doing is you are making the molecule further and further apart, but you are not breaking the covalent bond at all. This was year 9, structure, bonding, property of covalent compound. I can see the question being like this, but I cannot guarantee the question will be exactly the same as this, okay, for your June or for your November exam. Now, let me ask you that, what is the effect? So this adverse is an English word. It means a harmful, a bad effect of carbon monoxide. So how is that very bad for you, Chayen?
It releases toxic.
It is
It is poison.
It is a toxic gas. It is a poisonous gas. It doesn't just release it. It is itself a toxic or a poisonous gas already, yeah? Anyway, so we're going to go back to respiration and complete combustion. What are the similarities? They said describe 2 other similarities. So they already mentioned one similarity, that is carbon dioxide is produced in each of those reactions. So you produce carbon dioxide. So what is your first similarity? What other similarity can you see that?
Both produces water.
Yeah, so both reaction produce water. Anything else?
Both causes global warming.
Not really, because this is sugar. Sugar doesn't cause global warming. I think you should look on the left-hand side. What do both react with? You see what do they react with? Do you see the plus 6O2? Do you see the plus 2O2? So these are called combustion. Combustion means you are burning them in oxygen. So the similarity is not just on the product side, but it's also on the reactant side, where both of them burn in oxygen. So both require oxygen in order to burn. Both require O2 or oxygen to combust. Happy with the idea?
Yes.
Okay. Hi, Balkis. Happy to have you joining us. I don't know what happened to the rest of the people. Not very responsible to just bail on me, but anyway. Let's just continue then. I hope you have this paper about this. All right. So I don't know if there's another chemistry questions. I think there's all the chemistry question in this paper actually. So what I can do now is I can go through the physics, but what I cannot go through is I cannot go through the biology. That one I really cannot do. Okay. So I'm just gonna go straight back to start of the page and let us just go through it very carefully. Actually, I was lying. I could do a little bit of biology. Okay, I can do a little bit of biology. Okay, why don't you tell me then, Balkis, what does the liver cell do? Any idea, Balkis? Not much idea. Cheyen, do you know what is the liver for?
It breaks down alcohol.
It does break down alcohol. So they say alcoholic people, okay? So alcoholic or drunk people. So this is general knowledge, okay? So they get damaged liver. So people who drink alcohol a lot, their liver get damaged. So that means it does help you to break down alcohol, but too much of the alcohol means that your liver is going to fail eventually because you make it overwork. Okay? I guess Balkis was disconnected, but anyway. Mesophyll cell is present in leaf. So what is the use of mesophyll cell then, Shaya?
As a glucose production.
It's definitely for glucose production because that is present in your leaf. Because if I look at the rest of these, pancreas is present in human being, red blood cell is present in, well, not plants. I can tell you, it could be human, it could be animals, and root hair cell is in plants, and then white blood cells again is in not plants. Okay, so if I instead of saying human, because animals does have pancreas, so this is not plants again. Red blood cell, we are very good with red blood cell. This is what is present in your, well, this is what makes the color red for your blood. So is Balkis around already? Is your microphone working, Balkis?
Yeah.
Okay, good to have you join us. So what is the use of red blood cell then?
Oxygen transport.
Definitely, because that is what you use in the body to transport oxygen around the body. Now, white blood cell. So Chayan, white blood cell, back to you. What is white blood cell used for? Do you have any idea?
Antibody formation.
It does, because I'm not sure if you had done the biology topic yet. So we need white blood cell to fight off infection. So the thing about COVID is also they are looking for a spike in your protein when you do the COVID test. And the spike in the protein is a body mechanism. When you eat something which has poison food or whatever, then your stomach is gonna get stomach ache. And that's why you go to the toilet a lot and try to get rid of it from your body. White blood cell is your body antivirus. It's your, like computer has antivirus, white blood cell is in the body. It try to create antibody in order to dispel and also fight all those bacteria and whatnot. Now we're left between enzyme production and water absorption. So what is root hair cell for about this?
Water absorption.
That one is quite obvious. So root hair cell doesn't cause you to produce enzymes, and pancreas produces the enzyme. See, the first question, they try to give you the 3 easy marks. Try to read through the idea instead of just matching them up. Try to think about the ideas what you have done previously. Yeah. It could be a chemistry, it could be a biology, it could be a physics questions. Not necessarily just biology there. I've done the chemistry side. I can do the physics as well. So calculate the change in speed. Now, first of all, when you have a graph, you must learn to circle and underline a few information. The first one is about speed. Okay, this is the speed of a racing car. So what they could also do is sometimes they could do speed and then stroke, then meter per second. So this means that is the unit, that is the quantity. This is common in lower secondary sciences where they say level and then stroke the unit. They can put the unit in bracket, but in O-level, in upper secondary, usually we just say stroke, then the unit. Same thing there, that is the quantity called time, and that is the unit of the time in second there. So we have a couple of formulas that we know. We know that speed equal to distance over time. The distance in meter, the time in second, distance over time. So that means meter over second. That is why our unit of speed, probably level is speed, so that we're not confused between second and speed, is going to be meter per second, because meter divided by second is meter per second. How many meter in 1 second? That's the meaning. How many meter in 1 second? Now we also have this thing, uniform acceleration. So we know acceleration formula, don't we? Chayan, what is the formula for acceleration? Any idea?
Change in speed divided by time taken.
All right, so acceleration is your change in speed over your time taken. So this is going to be change in time, essentially, okay? Now, we're going to be following units. The thing about physics is you must follow the units. So speed minus speed. Speed is in meter per second. So it's like 10 orange minus 1 orange. You're going to get 9 oranges. 10 meter per second minus 1 meter per second. You're going to get meter per second on the top. At the bottom, our time is still in second here. So this is change in speed. So there's meter per second divided by the time in second. So when you think about meter over second divided by second, you have meter over second times 1 over second. That is your primary school mathematics. Meter per second change in speed divided over second, the time. So meter per second times, because I want to change divide into multiply, 1 over s. So I'm going to get meter per second squared, because s times second give me second squared. So the unit of acceleration is meter per second squared. That is how you get the unit of acceleration correctly. Okay, I hope that makes sense there. I am just going to move on to the question now. Calculate the change in speed of the car from point A to point B. So our point A, the speed on the y-axis is 30, and B, the speed is 60. So the change is final speed minus initial speed. Final mean at the end, initial mean at the start. So at the final speed is 60 meters per second, and then I have initial speed, which is 30 meters per second. When I do physics, I love to write down the units so that I could see exactly what is going on. As I mentioned, it's like 60 oranges minus 30 oranges. I'm going to get something oranges. On your calculator, they should give you 30 as well. Hope both of you can still follow, yeah? Now calculate the time taken. So some people, they usually just read the time here, but that is wrong. Where do you start from and where are you ending? You start from 45 seconds and then you end at 60 seconds. So we are not looking at 60 seconds on its own. We are looking at from 45 seconds to 60 seconds. So again, final time minus initial time. So it's always where is your final destination and where do you start from? So that is 60 seconds minus 45 seconds, and I get 15 seconds. The unit is already given there. According to Cheyenne, the formula is already given, so it seems like they are pretty generous in combined sciences. So this is 30 meters per second top, divided by 15 seconds, then your unit is meter per second square, and hopefully you should get the answer on your calculator, 2 meters per second squared. Are you both still okay? Okay, still okay?
Yes.
Cheyenne, okay?
Yeah.
Okay, can follow, yeah? Okay. So you have your paper in front of you, so that's why I printed the paper for you. It's easier for you to follow, okay? Now, use your answer to A part 3. This kind of question, they usually ask you to use your previous answer. How about you say, if my previous answer was wrong, can I still score? Yes. If you use your answer and you do the working correctly, there is something called ECF. This is called error carried forward. These kind of marks are for calculations that involve the data from the previous question. Use your answer to the previous part. So you might get the last part wrong, but that's why you get awarded for working if you show the working and you get the answer which is wrong, but based on the method which is correct, based on the wrong value. Earlier, you have been penalized if you got it wrong, but here you have gotten the full mark because you have done everything correctly except using the wrong value. Okay, so don't leave it blank, right? Now you want the force. This is called F equal to ma. So F equal to ma is Newton's second law. So I hope you have done this in physics. So that is force. Force will be in Newton. M will be the mass. The mass must be in kilogram. And last but not least, the acceleration. What we just calculated previously, that was change in speed over time. That was meter per second squared. All these are from your year 9. So I want the force. Be careful with the units. These are kilogram. So I am okay at 725 kilogram. I purposely write down the unit so that I remember. This is 2 meters per second squared. So they're trying to guide you step by step. If they don't guide you, they will give you 3 marks. Then you have to do it all in one go. Now you just need to press the calculator now. 725 times 2, 1450. Your final answer will be Newton, because Newton is equal to kilogram times meter per second squared. Okay, so now one force acting on the car. So this is the car. So they say that it is moving forward because it is accelerating. So that is your 1450 Newton. What is one force acting on the car? So what do you think about this? What other force is there on the car?
Friction.
Friction. So which direction is the friction then? What do you think about this? Is it in the same direction as the force?
Opposite.
Opposite, because that is what friction means, okay? So we are not living in an ideal world. We do have friction going this way. There is another force acting on the car. So do you know what it is, Cheyenne? There's supposed to be another force acting on the car. Any idea, Cheyenne?
Mm,
So when you stand
not
up,
sure.
when you stand up on the ground, you're not falling, right? You're not falling. If you throw an apple, there's the very famous experiment from Isaac Newton. Isaac Newton saw the apple from the tree always come down. You throw the apple up, the apple always come down. Why does the apple always come down, Cheyenne?
Because of gravity.
Okay, now do you think the car can fly? The car cannot fly, okay? So the car has a mass, so that is what you call a force. What is this force called, Cheyenne? The one which is acting downwards. It has a name.
Gravity.
No. This is called weight. Weight equal to W, W equal to M times G. Have you ever learned this before, Cheyenne, in, I don't know, year 9, year 10? Is this in your syllabus?
Yes.
There you go. So this is called the gravitational acceleration. Gravitational acceleration is like F equal to ma. This is the mass of the object in kilogram. This is acceleration in meter per second square. And therefore, this is just another force, and this is in Newton. Okay, so I hope that makes sense there. I'm just going to use a different color so that we don't get confused with it being, with it being the other force. I mean, this is direction of the force. The weight is always coming down. This is the friction going the other way, but you must have greater force because the car is moving in this direction, but friction always go opposite your motion. They don't want you to draw. Sometimes they want you to draw. So you can say friction, that is one choice, but they just want one. So you could also mention weight. So either one would have been correct there, just for that one, yeah? Okay, so you both still all right with this physics question? If you got any question, just stop me at any point, yeah? Okay, I'm going to move on to the next one now. Happy for me to continue, or do you need some time to write down some stuff? Balkis, okay?
Yes.
Cheyenne, okay to continue?
Yes.
All right, now on to the next one. Food chain, okay? I'm not very good with food chain, okay? But use the information in the box. So this is more like English comprehension. So in your English exam, you would probably be given some information, blah, blah, blah. Yeah, so draw a food chain containing these organisms. Eagles get it from sparrow. So which one eat which one? Balkis. Eagles obtain their energy from sparrow.
Eagles eat sparrows.
Eagles eat sparrow. So we are saying that sparrow get eaten by eagles, okay? It's like in chemistry, we call it reactivity series. You have to decide which one is more reactive. In biology, you decide which one is the prey and which one is the predator, okay? Prey versus predator. Cheyenne, have you heard of this word before? Prey versus predator. Are you okay with this word,
Yeah.
Cheyenne? Okay, Cheyenne, which one is the prey and which one is the predator?
Sparrows is the prey, and eagles
Okay.
is the predator.
Is that correct, Balkis?
Yes.
Okay, sparrow is the prey, and then this is the predator, okay? Now, anyway, oak tree carry out photosynthesis. So that means oak tree is the plant, and plant is your source of energy. So we always get our energy from plants. So a lot of food chain, they all start from plants because you say you don't eat vegetable, but you eat meat. and meat come from animals which eat vegetables, which eat plants, which eat grass. Okay, so sparrows are carnivore. What does carnivore means to you, Balkis?
They only eat animals.
They are meat eater. Okay, they can even eat human being if they want to. So it's like tigers. Then you say you like tigers because tigers only eat animals, but tigers also eat humans because they eat anything that meat. Okay. Now caterpillars are herbivore. What does herbivore mean to you, Cheyenne?
Plant eaters.
Okay, so they eat plants. So those are your plant eaters. Okay, now so it looks like sparrow are carnivore, caterpillars are herbivore. So which one is going to be eaten by which? Sparrow versus caterpillar. Which one do you think is going to be eaten by which? What do you think, Cheyenne?
Sparrow will eat caterpillars.
All right, so sparrow eat caterpillar. Now, I mean, you can process this in your head, but I'm just writing it out so that we can see what's going on. Do not draw pictures. There are some people who are very artistic. There's so much time. This is 3 marks. So we got to use arrow. Draw a food chain. Wait, do you guys normally draw food chain using arrow left to right, or is it going up?
Left to right.
Okay, cool. So what do we start from here about this?
Photosynthesis.
No, photosynthesis is the process. Food chain is about your source. Photosynthesis is the process that allows the oak tree to become food. Okay, so the oak tree is going to be eaten by what about this?
Caterpillar.
Yep, and then based on what Cheyenne said, the caterpillar will be eaten by sparrow. And then according to, I think what you said earlier, Balkis, the sparrow get eaten by eagles. And just like that, there are 3 key information here. What eat what? Okay, what eat what? There's the whole idea there. And this kind of 3 marks, you should be able to score easily, okay? I hope, all right? All right, now the next 2 marks. Explain why both animals. Now, this is a trick question. Why both animals and plants are dependent on photosynthesis. Now, first of all, you must know what is photosynthesis. What is photosynthesis? Number 2 is why. So that's why there are 2 marks. Okay. Now, we're going to go straight to what we know. What does photosynthesis involve? It's not how much you write, but it's whether you can get straight to the point of it. Tell me what is involved in photosynthesis, Cheyenne. What reacts with what?
Carbon dioxide reacts with glucose.
No. Carbon dioxide doesn't. Is it with glucose? No, it doesn't react with glucose because plants give you food. You see, plants carry out photosynthesis. You get glucose. You produce glucose. Then that is eaten by caterpillars, and caterpillars get the energy. So you don't use glucose, you produce glucose. So be very careful about your photosynthesis, yeah? So, Balkis, you want to correct her about this? What does carbon dioxide react with?
Water.
Yep, so carbon dioxide reacts with water. This was the opposite. Actually, in this paper just now, Chayan, I don't know whether you remember the respiration questions. I think it was the last few pages, right? Where was it? Photosynthesis is the opposite of respiration. Photosynthesis is the opposite of respiration. There you go. This is respiration. Humans, animals, we respire. We burn glucose in our body. We burn calorie. We burn glucose in our body. We get carbon dioxide and water. And that is exactly what Balkis just described. Carbon dioxide reacts with water to give you back glucose and oxygen gas. That is photosynthesis, which is the opposite of respiration. I think in biology, you don't need to know the chemical equations, so you just need to know how to write the word equations. So that's glucose plus your oxygen. Now, why is it important? This is the key thing. Why is it important? Number 1, why do animals need photosynthesis? What can you tell me, Cheyenne? What about photosynthesis that animals need?
They need it to survive, to breathe.
Okay, which one? Which one from there do we actually need by animals?
Oxygen.
Okay, animals need oxygen for what process? Cheyenne? What is the name of the process? What do we need oxygen for? Like you are currently breathing in oxygen.
Respiration.
Why do you, yep, respiration. But do not forget that you also need the source of energy. So this is your glucose as your source of energy. Because some people are vegetarians, and of course they get their source of energy from like carbohydrates, like potatoes or flour, like that kind of stuff. Yeah, a flour as in like not the flour, but the pronunciation of this is flour. Okay. Now we are also talking about plants. So what do plants need photosynthesis about this? Why do plants need photosynthesis? What do you think about this?
To make food.
Yep, so plants and animals. Okay, actually, just plants. Animals use the food, but plants need photosynthesis in order to make food. And earlier we saw the questions where in the cell that you actually carry out photosynthesis. That was just the mesophyll cell in the leaf where the glucose is produced. So this could be a state question. It could be a multiple choice question. It could be a fill in the blank question. It could be a listing and matching kind of question there. Okay. So the questions are kind of related actually. I said I'm very bad in biology, but apparently I am okay-ish in biology. All right. So that wasn't exactly true. Okay. Number 6. So this is back to physics questions. So this is about balancing the beam. So you think about balancing because what do we have? We have an object. This is what you call the weight, because the weight is coming down. So this thing will tilt this way. You need something here. You need something there in order to counterbalance it, counteract the moment. So this is an anti-clockwise because this is going against clockwise, whereas this one must be going clockwise because this counterweight must be in the opposite direction. So this one is called clockwise. We're going to be talking about clockwise moment. And then the blue one on the left, that must be the anti-clockwise moment. Now calculate the moment. Calculate the moment. Now, how in the world do we know the formula for moment? I'm going to tell you how you can get it. Physics is mathematics. Trust me. Your answer must be in Newton meter. That's the first rule. Your answer is in Newton meter. So what do we know by Newton? Newton is the unit for force. Earlier, we said force equal to mass times acceleration. Okay, so that is your mass. That will be in kilogram. That is your A, which is in meter per second square. Now, this is an object that is acting downwards. That's acting downwards. So we are not really talking about force as in force. We're talking about W equal to N times G, which is still F equal to MA. But this is going downwards. This could be going left and right. It could also be going downward. Weight is like the Newton apple. It's always coming down. It's always coming down. The mass must be in kilogram. So it's 1.7. The acceleration is the G. That means that is the gravitational field strength. So that is Newton per kilo. So that's actually the gravitational acceleration. They call it the field strength. If you follow the units, I hope you can see the units. That was 1.7 kilo. And then I multiply that by 10 Newton over kilogram. That's why it's W equal to mg there. Okay, can you see the units cancel out? So you have the kilogram divided by kilogram, just like your mathematics, and you get your final answer, 70 Newton there. Are you both still okay?
Yes.
Jane, okay. Balkis, okay. Can you follow the units? Are you lost, Balkis?
Yeah, but the connection right now is a little bit bad.
Okay, all right. Now, so the formula is W equal to mg. In physics, they always tell you that, formula. But I would advise you to think about units. One thing they never really, emphasize is units. Units are very important. W equal to mg is the same as F equal to ma. So it's basically F equal to ma, but it's going upward and downward. It's always going downward because, it's gravity. So they don't give you the acceleration unit, but they give you a Newton per kilogram. Newton per kilogram. So this is G there. Newton per kilogram multiplied by kilogram. The kilogram will cancel and you will get the weight, which is the force acting downward. You want the final thing to be in Newton meter. Newton meter means Newton multiplied by meter. Newton multiplied by meter. I have already obtained Newton. So how do I go Newton multiplied by meter? That is why I need the distance from the pivot. This is in meter. This is in meter. So how in the world do I get moment, which is Newton meter? So this is moment. Look at the unit. Moment is going to be force times distance. And this has to be perpendicular distance because this is Newton and the distance is meter. Newton times meter. Newton meter. The unit is the answer. The unit is the working, and they will give you the answer. Okay, I already have the 17 Newton. I just need to multiply by 0.24 meter. And that is how easy it is to get the 3 marks. I'm telling you, this kind of 3 marks at the start is a free giveaway. Follow the units step by step, and you should be able to get to the correct answer. Are you okay now about this? I guess the connection is really choppy about this. Are you still there? Hello, Bakis, are you still there? Okay, it's probably a bit choppy, okay? Yeah, you're probably about to say something, but okay, never mind. You can always rewatch the recording later, yeah, for the bit that you missed, okay? Now, the next thing for 2 marks questions, they want you to find volume. They give you this thing called density. It's like you always ask, there's so many formula, how do I remember it? There are some stuff which are basic, and then I tell you, the unit is the formula. I keep on telling students, the unit is the formula. So look at the unit. What does the unit tell you? 6,800 kilogram over meter cube. So this means kilogram per meter cube. Kilometer per hour. How many kilometer in 1 hour? Even you know that. How many kilometer in 1 hour? So kilogram per meter cube. That means how many kilogram in 1 meter cube? So what is the unit of kilogram for? This is mass. This is volume. How do I know it's volume? Because the unit is 3-dimensional. Length times breadth times height. That one is your mathematics, maths D. Okay? Or your IGCSE maths. Length times breadth times height. That is your volume. So what is the volume of this thing? Well, I need to know this is density, first of all. So density is equal to mass over volume. I can know this formula, or I can see from the units, mass over volume. It's very obvious, mass divided by volume. What do they want? They want volume. So what do? I bring up the volume to the other side first. You can try and do it step by step. Don't try and do everything in one go. So volume multiplied by density because I bring up the thing at the bottom. If you cannot see this, I can put a density over 1. That means V goes up because density over 1 is density. So V goes up, that means V multiplied by density is the same as density multiplied by V, equal to M. What do you want? You want V. You want V. So I am going to move the V to the other side. Actually, I'm going to move the D to the other side. This is multiplied by D, okay? You don't actually have to circle and underline things in your calculations. I'm just showing it to you because I don't want you to make that mistake. D is multiplication here. When I move D to the other side, it becomes divide because that is your general rule of mathematics, right? So M remains, but it becomes divided by D. Is anyone lost? Are you okay about this? Are you okay, Cheyenne?
Okay.
All right, okay, how about this is all right. Now, I have gotten my formula. So once I gotten my formula, V is equal to your 1.7 kilogram divided by 6,800 kilogram per meter cube. Now, I don't want to, like, you don't really have to write so much in your working, but I just want you to see what is actually happening. You can press a calculator now, 1.7 divided by 6,800, and your calculator should give you an answer which seems a bit funny, but you should know how to write it on your calculator. Your calculator show you 2.5 times 10 to the power minus 4. Okay, now this times 10 to the minus 4 must be written down. In your mathematics, they will say this is standard form. This means it's a very small number. Okay, so it's 0.00025. So it's actually 1, 2, 3, 4. So that's why we move 4 decimal place there, to give us 2.5 times 10 to the minus 4 standard form. However, this thing, the more zero you write, the more mistake you're going to make. So when you look at the calculator, do not write 2.5. Make sure you write in the times 10 to the minus 4 inclusive in your answer. So both these and these are correct. It's just that some people cannot get these on their calculator. So you must learn how to write that on your calculator. Okay. The last question, this is about balancing it. So why it is balanced in terms of moment. So this is called the principle of moment. So what is the most important thing about moment? So the clockwise moment, or you can start from the anti-clockwise really. The clockwise moment must be balanced. So it must be exactly balanced by the anti-clockwise moment. So it's like earlier I show you something is rotating clockwise. The weight of this object is coming down. So that is going anti-clockwise. But then we also have something going clockwise because we have this object. This object has a mass. The mass of this object is somewhere in the middle, because this is the middle of the beam. We call this the center of mass, because if it is completely uniform, your center of mass is going to be somewhere in the middle, where it's exactly half of that. Okay, my diagram might not be perfect, but hopefully you get the idea that it must be somewhere in the middle. So that means we have mass coming down. The thing is, we need this distance. What is this distance there? And we need the mass in kilogram of this beam. So this kilogram multiplied by 10 Newton per kilogram will give us the weight, multiplied by the distance from the pivot will give us the clockwise moment, equal to the anti-clockwise moment, which we just calculated. That is what is meant by clockwise moment, must be balanced by equal and opposite anti-clockwise moment there. Okay, now this is still there. I guess the connection is really choppy then, okay. All right, never mind. Okay, let me just continue on this. This is a biology question, so perhaps you can help me with this. Okay, I'm terrible with artery and veins. Chayan, what do you think?
The wall of a vein is thinner than the wall of an artery.
Is that correct? Do you know why? Where does blood flow out? Does blood flow out from the vein or from the artery?
From the artery.
So it's artery going to the vein, right? So if you want to go from the artery to the vein, which one will have higher pressure, the artery or the vein?
The artery.
Yep, because we are talking about pressure. So it's like when you want to push something, you go from high pressure to low pressure, right? So this will be higher pressure. Now, to survive the higher pressure, because you have blood pumping out at higher pressure, this one is lower pressure. So of course, you can imagine why your walls will be thicker and why your walls will be a little bit thinner, because to survive the higher pressure, you must be a little bit thicker, but the pressure is a bit lower when you pump up from the vein, because that's where the blood goes into. So, they don't need as thick of a wall in your vein. Okay, happy? Okay, so veins carry blood. So what is this? Carry blood away from or towards the heart? Huh? This is what you really have to help me with. I have no idea.
Away.
Oh, Balkis got away as well. Are you there, Balkis?
Yes.
Oh, so the audio is back. Okay, so the veins carry blood away from the heart. Are we sure this is thinner then?
It should be towards the heart.
It should be towards the heart, is it? Oh, the bulky said away or towards?
Sorry.
I don't know. Hang on. I am very bad with biology. So I'm just gonna quickly check the mark scheme, okay? Because it's better to just get it right because I don't want to risk getting it wrong. So this is November 22, paper 2-1, section 7. Just 7. So there's thinner. Thinner is fine. Towards the heart is fine. So carbon dioxide and higher. So what do they say? The blood in most veins contain more carbon dioxide. This one I know. Because if your blood goes from the artery, then there will be high in oxygen. That is how you pump all the oxygen to the rest of the body. And then when it passes through the rest of the body, it's going to have lesser oxygen. And it's going to carry more carbon dioxide. So this one will have more carbon dioxide, more CO2. This one will be less CO2. And that's why the veins will contain more carbon dioxide because it's a circulation in the body, right? And the blood in the artery is, of course, at a higher pressure. So we talked about this earlier, and I was right. So my biology is not so bad, okay? So this was a higher pressure, and they will get pushed towards the rest of the body. And when you return back into the vein, back into the heart, it's going to be at a lower pressure. Okay, so then we can move on to the next one, which should be a physics. Is it? No, it's a biology question again. Okay, can I skip this first? I'm going to go to the physics question first. I think I can do physics better than biology. Now, this one is about extension of a spring. So you should have learned this as Hooke's law. Do you guys learn it as Hooke's law, or do you guys call it something differently?
Same.
Same, Hooke's law, okay. So what does Hooke's law say? Hooke's law says force is equal to constant time extension. Am I correct? F equal to K times X. They call this force constant, is it? Am I correct? They call this force constant time extension. Is this what you guys learn in school? Can someone confirm this? You guys even learn the formula? Or is that pure science? I don't know. Do you learn this, Cheye? It's okay to say no.
It should be in the syllabus.
Let me double check. Okay, I don't know anything about the physics part, yeah, because it's not my area. You mean extension is no longer in the syllabus, is it? Are you saying it's no longer in the syllabus, Cheyenne?
I think that it's in the syllabus.
Okay, but the thing you're not sure about is the formula, right? So let me just type extension. It is in the syllabus. Okay, they don't call it force constant, they call it spring constant. Nearly correct. Okay, so it's to do with a spring. This is in 23.5.2. So let me just share with you my screen. Let me see. Share. Desktop. No, preview. Okay, can you see my PDF document? Can you guys see my PDF document? Is it showing?
Yes.
Okay, so that is your 23.5, and that is your 2023 syllabus. So 23.5.3, spring constant equal to force over extension. What I've done is I remember it's F equal to Kx. So when I want to find K, so what is K then? K equal to, that is K multiplied by F equal to Kx. So I'm just gonna share back my pad. Where is my pad? Okay, are you seeing my iPad screen again? No. Okay, it's back online. Okay. So if I have F equal to Kx, make K the subject. So I'm gonna make K on one side. So K doesn't move. Instead, I'm gonna move X to the other side. So that was K multiplied by X. I'm gonna get F of X. So this is called the extension. This is called the force. This is called the spring constant. And usually this kind of thing comes out in practical. So this is a real practical, which means rather than asking you in paper 2, it can come out in paper 3, which is alternative to practical. So they could ask you to read the spring thing and see the force and stuff. So now we're just going to do this. She add a lot of 9 newtons. So there's the force because the unit of force is newtons. And next one, we have an extension of 7.0 cm. We're going to plot this point, number 1. And then you're going to draw a straight line. There has to be a straight line from the origin, so from 0, 0. Because when you don't put any force in it, they could ask you, why do you start from 0, 0? When there is no force, you don't apply any force on the spring. Therefore, no extension. That's why you start from 0, 0. You don't apply, you have a spring, you don't pull it, you don't apply force, then why would it extend? It just stay on its own, right? Stationary. Now, we're going to use this formula now, F equal to Kx. So we're supposed to find something. We have extensions. We have 9 newtons. So when we put 9 newtons, so it's saying that when we have 9 newtons, if you look on your graph, this is 8, this is 10. So 9 must be somewhere in between. Make sure you can read the graph properly. 9 is somewhere in between 8 and 10, exactly in between. And our extension was 7 cm, 7.0 cm. So 9 newton and 7 cm is going to be halfway in between 6 and 8 cm. So we're looking at exactly halfway. We're looking at halfway between 8 and 10. We're looking at halfway between 6 and 8. So use a cross. That's what I say, use a cross. Then plot it past the origin. So from the origin, get a ruler, extend it. So they say from the origin to the plotted point. So I shouldn't extend it. From the origin, number 1, to the plotted point. My plotted point is there, so don't extend it. To the plotted point. They don't say extend it. So follow instruction carefully. Read and circle and underline and read again after you put down the answer. Now the load is removed and the spring returns to its original length. Now you add a load of 12 newton. Determine the extension. Extension is on the y-axis. Determine. That means use the graph, draw lines. Use your ruler on your graph, draw some lines. This is now 12 newton. This is on the x-axis, which means I actually do need to extend my line. So when I extend my line, let me see. I don't like that. I said don't draw it earlier, but it seems like you do need to draw it because otherwise you cannot do the next part, which is getting it to 12 newtons. So you do need to get your ruler down there and put in this value, which I'm going to do using dotted line. And then use your ruler to read whatever reading this one is. That is not good. So it should be there, I think. Yep, should be there. And I mean, do it on your own diagram, yeah? I'm just doing on my diagram. But what reading do you read here about this? What do you see about this? What is the y-axis reading then?
9.3-ish.
9.3-ish. Okay, that is not a very good choice because you have 5 boxes. You have 5 boxes, but there is a difference of 2. So it's like 2.0 divided by 5 because you have 5 boxes. So what is the value of each box? It's 0.4. So how many boxes are you? 1, 2, 3. So you have 3 boxes above 8.0. 3 times 0.4 is 1.2. So it's 8, 8.4, 8.8, 9.2. It's not 9.3 dear. Okay, it's 9.2. Of course, it depends on your own diagram, but you got to be able to read very carefully from your own graph, yeah? Anyway, suggest one assumption. when determining your answer to be. Remember earlier, the graph was up until here, but then I have extended the graph. By drawing the same straight line, I'm assuming it follows this relationship f equal to kx. That is my assumption. But it says suggest, right? Suggest what happened there. So I'm just going to look at the marking scheme. What do they use exactly? Okay, I'm not very sure. But I know it must follow. That means it doesn't. Okay, that's the word they said. Elastic. They say it is still elastic. So you must assume the spring is still elastic, i.e., sometimes when you extend the spring and then when it's too much, it becomes deformed. Deformed meaning it changes its shape. It doesn't go back to being, the spring itself. So it's no longer elastic in that case. It's like a rubber band. Your rubber band can extend, but you use the rubber band again and again, and then eventually it doesn't go back to being the original rubber band anymore. It becomes inelastic anymore. That is when it doesn't follow the relationship. So i.e. it still follow the F equal to Kx relationship. In the marking scheme, they say the force is still directly proportional. So the force is still directly proportional. So in your lower secondary mathematics, you have learned about direct proportions. So this is to the extension. The K is a constant, y equal to mx plus c. So y equal to mx plus c, your y-intercept is 0. So this is y is equal to mx. F equal to kx. This is your y. Mx. So this is your gradient. And then your c is equal to 0 because it cut through origin. So this is your x-axis, and that is your y-axis. Again, this is in your mathematics. I'm not sure about IGCSE mathematics, but Cheyan, do you do y equal to mx plus c in IG mathematics?
Yes.
Okay, so you know about y equal to mx plus c then. Okay. All right, it's now 9 o'clock. I think that's it for 1 hour. That should be enough, and we can continue the rest. The next time I see you, I'll try and print another paper for you. But can't keep on printing paper. Eventually, you might have to print one paper on your own, and then we can go through it. How far along in biology are you guys with the syllabus? Do you know? Nearly finished? Still a lot?
I think 3 more topics.
Okay, but physics should be almost done, right, Cheyenne?
Yes, almost.
Okay. How is 11A about this? Physics and bio?
Physics, I think like 1 or 2 topics left.
Okay, how about bio?
And bio, the last topic we did was the eye.
I have no idea. You need to check through the syllabus. That's my point. Check through the syllabus and what you're missing. Beware that, what we did in the past year paper, I don't know about the physics and biology because I don't go through all those syllabus. There might be some stuff which are no longer in the syllabus. Yeah, just keep an eye out for those things. All right, cool. I'll leave it there for tonight. I'll share the PDF shortly. But the recording will be online for those people who can't make it tonight. Okay, then. See you tomorrow. Bye bye.